Hi scholars, welcome to Science Story Time. I'm just kidding, it's not Science Story Time, but you chose the option of me reading the text to you, which is totally fine. Please make sure you have the text open and you're reading along as you hear my voice. I want you to know that as you get older and older, you're gonna have to read more and more by yourself, especially like science textbooks and science material. And I don't want you to ever worry about not understanding every word. I promise you in college, there were some texts that I read and I did not understand every word that I was reading. But the goal is always to get the main points, the main gist of it, so that you can still learn from text. You won't always have Mrs. Vidon there to read it to you. But here we go, we're going to start reading. Remember, you can always pause the video and answer the questions on the notes that I provided for you. And I want you to follow along as I read. Let's go ahead and begin. Elements in the periodic table. Materials, both natural and human-made, have unique properties. Some are made of one type of element, and some are made of a combination of elements. But what are elements made of, and how do they differ from each other? Each element is made of tiny particles called atoms. A pure sample of an element contains many atoms of the same type. For example, the millions of iron atoms that make up a piece of iron metal are all the same type of atom and have the characteristics of iron. Iron atoms, however, are very different from atoms of other elements, such as gold or oxygen. The properties of each element depend on its atoms. Discovering elements. The idea that everything on Earth is made up of a basic set of elements began with the ancient Greeks more than 2,000 years ago. Greek philosophers thought that fire, earth, air, and water combined to make everything in the world. Starting in the 1600s, early chemists realized that fire, earth, air, and water were not the basic building blocks of matter. They looked instead for substances that they could not break down into simpler substances. These substances are known today as the elements. Some of the earliest known elements were carbon, gold, silver, copper, sulfur, tin, lead, mercury, and iron. All of the elements that occur in nature. Until the 1700s, very few new elements were discovered. But in the mid-1700s to the 1800s, chemists learned how to create chemical reactions and physical ways to separate pure elements. With these new techniques, they found dozens more elements. By 1869, approximately 63 elements were known. These included hydrogen, nitrogen, oxygen, sodium, and aluminum. Mendeleev and the periodic table of elements. In 1869, the Russian scientist Dmitry Mendeleev developed the ideas that led to the modern periodic table. Other scientists had some similar ideas, but Mendeleev made the most progress and published the first version of the table of the 63 elements known at the time. Mendeleev collected information on the properties of those 63 elements and grouped them in a way similar to what we did in our last activity. He used data that many other scientists had collected about the properties of each of the elements. When he arranged the elements according to their atomic masses and their physical and chemical properties, he noticed that there was a repeating or periodic pattern. For example, as the atomic mass increased from lithium to fluorine, the elements in between changed from metals to nonmetals and from solids to gases. He saw a similar pattern repeated from sodium to chlorine, and again from potassium to bromine. Mendeleev predicted that there were more elements that would fit into the gaps in his chart, the first version of what came to be known as a periodic table. He even used the patterns in the table to predict the properties of new elements. Other scientists used Mendeleev's ideas and built on them to identify the elements he predicted. Later, scientists found many more elements that follow the patterns he found. The modern version of the table is called the periodic table of the elements. Based on new data about the elements, scientists around the world have agreed on some changes to the arrangement of the table. The modern periodic table. Today, there are more than 115 identified elements, and everything on Earth is made up of these elements. Look at the current periodic table shown below. Each element is represented by a symbol that includes either one letter, such as C for carbon, or two letters, one uppercase and one lowercase, such as Ca for calcium or Cu for copper. Each element shows an atomic number that corresponds to its order in the periodic table, and an atomic mass, as shown in the example of the element carbon to the left. From the periodic table, you can find out a lot about an element. For example, if you look at the element cesium, atomic number 55, on the periodic table shown on this page, you will see that it is an alkali metal column. From this, you can assume that cesium is highly reactive, soft metal. On this periodic table, you can also tell if an element is a metal or non-metal, because a dark stepped line divides the table into metals to the left of the stepped line and non-metals to its right. Most of the elements that border the stepped line between metals and non-metals are called metalloids. Metalloids have chemical and physical properties intermediate between those of metals and non-metals. Aluminum is not classified as a metalloid because it has metallic properties. Metalloids are often called semiconductors because they conduct electricity better than nonmetals, but not as well as metals. Most elements are solid at room temperature. The 11 elements that are gases tend to appear on the right and near the top of the periodic table. Their symbols are shown in white. There are two elements that are liquid at room temperature, mercury and bromine. Their symbols are shaded in gray. You can also predict the chemical reactivity of an element based on its position in the periodic table. The reactivity of an element describes how likely it is to react or combine with other elements. An element that is very likely to react with other elements is described as highly reactive. This means that they will react with many other substances. The least reactive elements are the noble gases to the right. The most reactive metals are in the two columns to the far left of the periodic table. The most reactive nonmetals are in the halogen family in column 17. All right, make sure your notes are complete and you're ready for your Zoom class. I'll see you there.